So this is the Mechanics Lower 6th, Chapter 10F, and I'm going to start off with question 2. So the first thing to do is to fully understand the diagram. So what we can say here is we've got the weight going down with on P, an unknown weight which is K, Km times G. So Km is the mass times G. And always to set up, we have a pulley like this, you want to have equal and opposite tensions with the arrows pointing towards each other. Okay, now we can then choose to basically isolate P and just look at P on its own, or alternatively Q. And I've just put along this dotted line here just to help you focus on that. Okay, so anyway, let's answer part A. Calculate the tension in the string as Q descends. Now, if we're just looking at Q, okay, just focusing on Q, and we're going to use F equals MA. Now, the only forces in town are the 3M times G and the T. So, given that we are accelerating downwards, the 3mg has got to be greater than T. So our net forces are 3mg minus T, so that's our net force, and that equals the mass, which is 3m, times the acceleration, which is a third g. So just solving that, we get T equaling 2mg. So we can't work it out precisely, we still don't know what m is. Now for part B, we're being asked to show that K equals 1.5. So we're now moving over to focusing on P. Now P of course is going to be accelerating upwards, because on the right hand side Q is accelerating downwards. So as always, we choose to resolve in the direction of travel. Again, we're going to be using F equals MA, and again bearing in mind this dotted line here. Okay, when we're just looking at P in isolation, the forces involved are just T and KMG, and T wins because it's going upwards, so T must be bigger. So our net force on the left hand side is T minus KMG. So that's our net force. The mass of P is Km, and the acceleration of course is the same as with what Q is accelerating downwards. P is also accelerating upwards at the same acceleration. So that's a third G. So that gives us this. Okay, and then just following through the algebra, you will see that the m's cancel out. So we still don't know what the mass is, but it does allow us to work out exactly what K is and to show that it is 1.5. Now for part C, we've been asked to state how you have used the information that the pulley is smooth. Now because the pulley is smooth, there is no friction. That's the key point. And because there's no friction, the acceleration upwards for P is the same as the acceleration downwards for Q when you've got objects connected by a taut, inextensible string. Now, part D is a classic pulley question, so it's really important you get to grips with this. Now, it's obviously the question is all about P, but we can't really start until we know what the initial speed of P is on its journey. Okay, now the initial speed of P on its journey once Q has hit the ground is going to be the final speed of Q as it hits the ground. So the second that Q hits the ground, its final speed V will be the initial speed of P for its phase of the journey, its independent phase of its journey when it's travelling upwards after Q has hit the ground. So we're going to kick off looking at Q with the goal of finding what its final speed is. So we're going to be resolving downwards. We're told that the time it takes for it to descend to reach the plane is 1.8 seconds. Its initial speed is 0. And we know that its acceleration is a third g. So using v equals u plus at, we can work out that the final speed of Q as it hits the ground is 0.6 g. Now, what we can also work out for Q, before we move on to worrying about P, is this distance S1, the distance that Q travels to hit the ground. So still sticking with Q, and we're going to use S equals ut plus half at squared. So the initial speed was 0, so the first term is 0. Well, half times the acceleration, and then times t squared, which is the 1.8 squared. So we know that the distance S1 as Q hits the ground is 0.54 g. Now, this is going to be important a bit later on because we're being asked to show the greatest height in meters reached by P above the plane. So not above where it starts, above the plane. So think about it. The greatest height that P is going to reach is its initial height before it starts, which is S1. And then as Q goes down and hits the plane, and that obviously as that string gets longer, this one's going to get shorter, so that will be another S1 that P travels. And then finally we're going to have this extra bit of distance that P travels as the string goes all wobbly, and P just keeps on going up, fighting against gravity before it meets its final height. So it's really important that you understand the greatest height above the plane that P will make is S1, its starting position, plus S1 again, because as Q goes and hits the ground, P will go up an S1, and then finally S2, which we're going to move on to looking at in a second. So now we're going to look at the journey that P takes the second that Q crashes into the ground. So just picture it, okay? Q's crashed into the ground and P doesn't suddenly just stop there, but it's got some momentum going upwards, isn't it? So it's going to carry on up a bit with the string being all taut until it reaches its maximum height, and then it will come down again and be taut again. So we want to work out that distance to its maximum height once Q's hit the ground, which I'm calling S2. So what do we know? Well, we know the initial speed of P for this phase of the journey is the final speed that Q was going at as it crashed into the ground, which is 0.6 g. Now we're resolving upwards, so that's going to be positive 0.6 g. Now at the top of the bounce, when it gets to this very highest point before it comes down again, its final speed is going to be 0, and it's fighting against gravity, so our acceleration is minus g. So using v squared equals u squared plus 2as, we can work out that this distance S2 is 0.18 g. So the distance travelled is an S1 plus and an S2, but because we're taking the distance above the plane, we're adding on that other S1. Okay, so the final height S2 gets at, that P gets at, to reiterate, is an S1 to its starting position, another S1, the journey it did as Q hits the ground, and then finally S2, the journey it does when it's on its own fighting against gravity. So I hope that's cleared things up for you guys.